Some of the most important security warnings in the autonomous systems industry never make it out of the meetings where they're raised, which means most security leaders only learn about them after they've shipped. I spent 25 years in security leadership, including time as the head of security for Amazon's Primary drone delivery program. That work put me inside some of the rooms where these decisions get negotiated long before the rest of the industry sees them. Here's the question I want you carrying throughout this video. Does the control you're relying on still work when no human is watching? The drone industry is the leading edge, but the same patterns are already shaping self-driving cars and also the AI agents your company is deploying right now. Most coverage of drone security treats it like a niche problem. A hobbyist hijacks a consumer-grade drone, a military drone gets jammed, commercial drones with security vulnerabilities. It's interesting to a point, but I think the framing is wrong. What's happening today in the commercial drone delivery industry is really just the leading edge of a much bigger pattern. Every time we remove a human from a system, the security assumptions that worked in the human-in-the-loop version stop working. The system functions in normal conditions, but we don't really notice until an attacker shows up. Now, a little history here. Commercial drone operators have been pushing for something called BVLOS, which is beyond visual line of sight, in their operations for many years. But the industry moved faster than the regulators. So now in that industry, we have some human pilots who can't physically see the drone they're piloting. That's what BVLOS is all about. And the policies being shaped today will allow more drone operators to do the same. Self-driving cars and AI agents have similar risks. The drone story should serve as an early warning. When I joined Primary, the engineering team had already settled on a North Star for safety. They talked about the difference between a horse and a car. You can drive that car into a wall, and the car will do exactly what you tell it to, even if it kills you. A horse will usually stop, because the horse has its own self-preservation mechanism. The vision for Primary's drone was to build a horse, not a car. A drone that was independently safe. Even if the navigation data is wrong, even if the GPS data is compromised or spoofed, the drone itself would have the sensors and the intelligence to say, something's not right, I'm going to stop until it's safe to proceed. It's the horse's instinct. It's an independent safety layer that doesn't require or depend on any one of those external signals being correct. That's what good autonomous design looks like. And to be clear, there are multiple ways to do this. I'm not claiming Amazon's approach is the only approach, but that's where the bar needs to be. Multiple independent layers that ensure safety. Yes, it's more expensive, takes a lot of work to build, test, and deploy those systems, but I believe it's the right bar because we're talking about public safety. Now, I want to be careful here because this is the part of the story most people get wrong. Nobody that I know in the drone industry sat in a meeting and said, let's go ship something unsafe. That's not typically how this works. What actually happens is more routine and frankly more dangerous. Three things converge when these discussions take place. First, there's enormous pressure to ship. Drones are a commercial race. You can't demonstrate return on investment until you launch. Typically, leaders who launch fast get rewarded, and eventually leaders who don't launch get fired. It's the same ship now, secure later posture that keeps AppSec and security teams busy a year after something launches. The second issue. Sometimes the regulators don't have the technical depth to challenge the industry consensus. They negotiate with industry groups, but the industry groups sometimes represent the loudest companies, not the ones with the best safety track record. And third, and this is the one nobody seems to be talking about, the path of least resistance is to take a control that worked in piloted aviation and reuse it in autonomous aviation. It looks rigorous, it cites prior art, checks some of the boxes. It also quietly assumes that a human is still in the loop, which they're not, at least not fully. There may be a pilot who's watching for issues, but by definition, BVLOS means they aren't able to visually observe what the drone is doing at any given point in time. That's how the warnings get buried. Not in a conspiracy, in 1,000 small meetings where people with varied motives are negotiating to define the minimum bar for security and safety. So here's the specific failure I want you to understand, because it's a template for everything that comes after. The Commercial Drone Alliance, an industry group representing a portion of commercial drone operators, has pushed a regulatory path with two parts. First, mandate that every drone broadcast its precise position, speed, and heading on an unencrypted channel, ADS-B. And second, remove the requirement for onboard detect and avoid systems. Their argument is that if every aircraft is announcing where it is, they can see each other and avoid collisions, which makes onboard detection sensors unnecessary. It sounds reasonable, and there are a lot of varied opinions on this topic, but there's an important detail it overlooks. A security attack that this line of thinking enables. How this attack unfolds in one of my previous videos, I'll link to it below, but the short version is this. Broadcasting position, speed, and heading by regulatory mandate hands to the attacker the missing data they need to spoof GPS and hijack the drone. And without an onboard detect and avoid layer, the drone is missing a key control that would help it avoid a hacker-induced collision. And the kinetic consequences here are real. Now, watch the same pattern show up somewhere else. In 2019, researchers at Tencent's Keen Lab published a paper demonstrating an attack on Tesla's autopilot. They placed 3 small stickers on a road. Stickers. A Tesla running autopilot read those stickers as lane markings, ignored the actual road, and steered itself into oncoming lane. Obviously, a human driver would have caught it instantly. The stickers are obvious. The lane the sticker suggested didn't exist, but the vision model had learned to trust lane markings as ground truth, and so the lane markings became the truth. Now that paper is years old. The specific exploit is probably patched, but that's not what makes this example matter. What's important is Tesla's official response. They said that the attack was not a real-world concern because the driver could easily override autopilot at any time. So if you read that carefully, you notice the defense is the human, which is fine until the human is gone. The product is called autopilot. The entire premise of full autonomy is that the human goes away. The dismissal rings hollow, and it's also super irresponsible. But there's a second pattern in that response that's worth naming. When an industry calls a working vulnerability academic, niche, or unrealistic, it's painting a target on its back. There are a lot of talented hackers out there who enjoy nothing more than proving confident tech leaders wrong in public. That's the same basic architectural pattern as the drone broadcast problem. A control that works when the human was the final check fails when the human is no longer there. And now if you couple that with a leader who dismisses the warning rather than fixing it, that problem is guaranteed to persist. Now let's bring it home for the security leaders watching. Your company is probably deploying AI agents right now. Some of them have access to your tools, your data, and your customers. Ask yourself, what's the independent control that catches the agent when it makes a bad call? For most teams, the honest answer is the model's supposed to be good enough. But that's not a control, that's hope. And hope is not a plan or an architecture. Prompt injection is like the agent equivalent of GPS spoofing. An attacker doesn't necessarily break the model. They give it inputs that look legitimate. And then, of course, the agent acts on those inputs the same way it acts on any other instruction, but without an intentional design decision. Without independent validation, the system has no layer to stop and say, wait, something's not right here, I need to stop. That horse model is missing. Drones, self-driving cars, AI agents, they're three different industries, but it's the same architectural mistake. They trust a single source, and they skip the independent check. So we come back to the question I asked you to carry throughout this video. Does this control still work when no human is watching? If the control was designed for a world where a human could intervene, catch an error, or override a bad decision, then that control is not sufficient on its own. You need an independent layer. For drones, that could be onboard detect and avoid. For self-driving cars, that's genuine sensor fusion that doesn't rely on any single source alone. For AI agents, it looks like output validation, guardrails, or independent monitoring that doesn't depend on the same model the agent is using to make decisions. The principle is the same. Autonomous systems need redundant, independent controls that catch failures the primary system cannot see. So I spent 25 years building security programs at companies like SAP Concur, Amazon, Disney, and AWS. The drone story is one I'm positioned to tell because I was inside it. It's not the only one. There are warnings about autonomous systems that don't get told because the people who know are also the people whose paychecks depend on keeping their heads down and not making noise. I'm not in that position anymore. So this is what I plan to provide with this channel. Some stories from the inside. NDA appropriate, of course, including the technical breakdowns of the patterns nobody else is talking about, and a running answer to one question. What is the autonomy industry shipping that it knows it shouldn't, and what should you do about it as a security leader? All right, so if you want the deeper version of this with the academic research on GPS spoofing, the regulatory back and forth, and a framework for auditing your own autonomous systems, that's in my newsletter, The Product Security Playbook. There's a link in the description. If you're new here, please subscribe. I'm publishing a new video every week on autonomous system security, AI agent security, and the warnings the autonomy industry finds inconvenient. The next video goes deep on AI agents. You're not going to want to miss that one. Thanks for watching. I'll see you in the next one.